Welcome to class. Ms. Tessler here. Today, we will practice drawing area models to show equivalent fractions. This time, we'll decompose fractions with more than one unit. All you need is paper and pencil or your personal whiteboard. Here we go. Remember to pause the video whenever you need time to draw, write, or think. And if it helps, imagine the area model as something you can visualize cutting into parts, like a loaf of bread or a piece of fabric. First, draw an area model representing 1. Partition the figure and shade 3/4. Great! Here is 1/4, and here is 3/4. How can you use this model to show the decomposition of 3/4 into 8ths? We need to make 4 parts into 8. I know 2 4s make 8. We could draw a line so that each of the 4ths is split into 2 equal parts. How many 8ths are in each 4th? 2/8. Notice where we shaded 3/4. How many 8ths are shaded? 6/8. Pause here. Describe this decomposition using addition. Ready? Maybe you wrote that we could add 1/8 6 times. Or maybe you noticed that 2/8 are in each 4th. And you added 2/8 3 times. Either of those would be correct. Now, try describing the decomposition using multiplication. Ready? Adding 1/8 6 times would be the same as saying 6 times 1/8. Adding 2/8 3 times would be the same as saying 3 times 2/8. What do these multiplication and addition sentences mean? What do they tell us about the fractions 3/4 and 6/8? We have the same amount shaded the whole time, but can decompose the units to make more, smaller parts. 3/4 and 6/8 are equivalent. Adding together all the smaller units equals the total of the larger units shaded. Multiplying also equals the total of the larger units shaded and is more efficient to write out. Great job so far. Let's try another. Let's draw an area model to prove that 2/3 is equivalent to 8/12. Partition your model once. What fraction will you model first and why? I'll represent 2/3 first, since thirds are the larger units. Then I can decompose them into smaller units. Here's 1/3, and here's 2/3. I created 3 equal parts, thirds. What other unit do we need to represent? 12ths. So how many parts do we need to make a whole? We need 12 parts. How do we make 3 parts into 12? Split each third into 4 equal parts. I'll draw 3 lines to decompose the thirds into 12ths. There we go. How many 12ths are in each third? 4/12. Notice where we shaded 2/3. How many 12ths are shaded? 8/12. Now, use addition to describe how you decompose the fractions. Show the decomposition as the sum of the smaller units. There are many ways to show this decomposition. Here are two you might have done. You might have added up 1/12 8 times. Or maybe you grouped 4/12 together to show each third. And added 4/12 twice. Now use multiplication. Express the decomposition as a product of the smaller units. Ready? Adding 1/12 8 times is the same as saying 8 times 1/12. And adding 4/12 2 times is the same as saying 2 times 4/12. Put a star next to the equation you like best to describe these equivalent fractions. Right now, we're practicing writing it in many ways to make our minds strong and flexible. As we practice, pay attention to which ones make the most sense to you and which ones best show what you're trying to show with your area model. Whichever one you like best, all of them show that 2/3 and 8/12 are equivalent. So far, we've drawn area models to represent one whole. Remember, we can also use fractions to represent amounts that are more than one. Follow along with me. Remember to pause whenever you need. Last week was my birthday, and brownies are one of my favorite treats. I baked 2 whole pans, but only ate some of them. This is how much I have left over. Here is one whole pan, and here is a little bit more. I made this line in between the whole and the extra really thick so that it's clear. Draw your area model to match mine. I have 5/3 pans of my brownies left. Partition the area model to show 5/3. What will that look like? The unit is thirds. That means I cut each whole into 3 parts. How many thirds is this so far? 3/3. And how many more thirds do we need to have 5/3? 2 more thirds. Split this part of the selected units in 2. You can imagine the part that I already ate here if that helps you think about what 5/3 means. Now the shaded area represents 5/3. These are big pieces of brownie, so I want to make smaller pieces. I want to split everything I have left in half. Draw one horizontal line to decompose 5/3. What do you get? Now how many units are in one whole? 6. So they are each what? 6ths. And how many 6ths are shaded? How many pieces do I have now? I have 10 6ths. Finally, write one addition and one multiplication sentence to show this decomposition. Here are some examples. You could show that 1/6 was added 10 times, which would be 10 times 1/6 as multiplication. Maybe you thought about 2/6 as each third, and added 2/6 5 times. That would be 5 times 2/6 as multiplication. You also might have thought about 6/6 in the whole plus 4/6 more. How would we show that as multiplication? We could show 3 times 2/6 to represent the whole, plus 2 times 2/6 more. All of these equations show that 5/3 is equivalent to 10/6. Great, so we can also use the area model to model fractions that are greater than 1. You've done a lot of great work today, and I think you're ready for the problem set. The must-do problems are on the screen. Set a timer or watch the clock for 10 minutes and work on